Fashion, like any industry, thrives on making the right choices. Now, this reinforcement learning is a powerful technique that enables agent to learn from experience and make optimal decisions. So today we will delve into the world of reinforcement learning, unraveling its concepts and entry cases through relatable example from the fashion domain. So let's understand what is reinforcement learning. Now, this reinforcement learning is a type of machine learning where an agent learns to make decision by taking actions in an environment to maximize a reward. So imagine you are a fashion influencer on social media and your goal is to maximize your engagement or reward in your post. Now you can choose to post different types of content or actions such as fashion tips, outfit ideas, or product reviews. Now this environment is the social media platform and the users who engage with your content. To apply the reinforcement learning in this scenario, you can create an agent that represents your social media account. Now this agent will take actions or post certain types of content and receive a reward or engagement on your post. Now this agent will learn what type of content leads to higher engagement or better rewards over time by exploring different options and updating its policy or decision making process based on the rewards received. For example, the agent might initially post a mix of different types of content to explore what works best. After the few posts, it might notice that fashion tips and outfit ideas receive more engagement than product reviews. The agent would then update its policy to post more fashion tips and outfit ideas. So over time, the agent would continue to learn and adapt its policy to maximize the engagement on its post. So this simple example demonstrates how reinforcement learning can be used to optimize decision making in a real world scenario by learning from environment and updating its actions to achieve a specific goal or maximizing engagement in this case. So let's understand it better via its important concepts. So first we'll understand what is state. Now the state refers to the current situation or environment the agent is in. In the fashion domain example, the state could be the current outfit, the user's body type and the occasion. So imagine you are a personal stylist and your client wants to pick up an outfit for a specific occasion. So this current outfit, the client's body type and the occasion are the state. Then comes action. Now this action is the decision the agent makes based on the current state. In the fashion example, the action is selecting a specific outfit. So as the personal stylist, you would select an outfit for your client body based on the current state, say its body type, occasion and current outfit. Then comes reward. Now this reward is the feedback the agent receives for taking a particular action in a specific state. So in the fashion domain, the reward could be the client satisfaction with the outfit or the number of compliments received. Then comes policy. Now this policy is the decision making process the agent uses to determine the action to take a given state. So in the fashion example, the policy could be a set of guidelines or rules for selecting an outfit based on the client's body type, occasion and personal preferences. Then comes value function. Now this value function estimates the expected cumulative reward for being in a particular state and following a specific policy. So in the fashion example, the value function would estimate the client's overall satisfaction with the outfit, taking into account the outfit's appropriateness for the occasion and client's body type. Then comes Q function. Now this Q function is the expected cumulative reward for taking a specific action in particular state and following a specific policy. So in the fashion example, this Q function would estimate the expected satisfaction the client would have if you choose a specific outfit taking into account the client's body type, occasion and personal preference. Then comes exploration versus exploitation. Now this exploration refers to trying new actions in the environment, while exploitation means choosing the action that has been previously found to yield the best reward. So balancing this exploration and exploitation is crucial in reinforcement learning to ensure the agents learn effectively. So in the fashion domain, this exploration would be trying new outfit combination that you have not used before, while this exploitation would be choosing the outfit that has been previously found to yield the best satisfaction for the client. Then comes temporal difference learning. Now this temporal difference learning is a method for estimating the value function or Q function by iteratively updating estimates based on the difference between expected value and the actual reward received. So in the fashion example, temporal difference learning would involve updating your estimations of the client satisfaction with an outfit based on their actual feedback and the expected satisfaction you had before choosing the outfit. Then comes Q learning. Now this Q learning is a reinforcement learning algorithm that learns the optimal Q functions by updating the actions taken by the agent in an environment that leads to the highest reward. Now this Q learning uses the temporal difference learning method to update the Q function. So in the fashion domain, Q learning would involve learning which specific outfit leads to the highest client satisfaction based on the feedback received and previous Q function estimations. Then comes policy gradient. Now this policy gradient is a reinforcement learning algorithm that learns the optimal policy by directly optimizing a policy function. Now this policy gradient algorithms update the policy based on the gradient of the expected cumulative reward. So in the fashion example, policy gradient would involve learning the optimal styling policy by directly optimizing the client satisfaction functions based on the client's feedback and the gradient of the expected satisfaction. Then comes deep reinforcement learning. Now this deep reinforcement learning combines deep learning techniques such as neural networks with reinforcement learning techniques. So this approach enables the agent to learn from high dimensional complex environments. And in the fashion example, deep reinforcement learning could involve training a neural network to predict the client satisfaction with an outfit using reinforcement learning techniques to optimize the network's parameter. So let's understand this reinforcement learning better using its Python code. Now this code implements the Q-learning algorithm, which is a popular reinforcement learning technique for a simple grid world problem. And the goal is to navigate an agent, which is represented as a state, through a 4x4 grid where each cell corresponds to a state. Now this agent can move in 4 directions, up, down, left and right, and receive a small negative reward of 0.01 for each step taken. And the objective is to reach the final state located in the bottom right corner where the agent receives an reward of +1. Now this code will define a Q table which will store the estimated values or the Q values for each state action pair. Now this Q values are initialized with small random values. So during the learning process, Q values are updated based on the observed reward and the maximum Q value of the next state. So the hyperparameters, which are the alpha or the learning rate, gamma or the discount factor, epsilon or exploration rate controls the learning process. Then the code runs the Q learning algorithm for a fixed number of episodes. So in each episode, the agent starts in the top left corner and tries to reach the goal. Now E-greedy policy balances exploration or the random actions and exploitation or the actions with the highest estimated Q values. So as the agent explores the environment and updates the Q values, it converges to the optimal solution where the Q values in the Q table represents the best path to reach the goal state from each starting point. So after this Q learning algorithm complements or completes, the final Q table is printed showing the estimated optimal actions for each starting point. So after running this code, you get the results like this where it is showing the final Q table. Thank you.